So if you haven't noticed, we're going to eliminate our break. If anybody needs to go. All right, so you'll have to share my screen at the end.
Wrong presentation.
Sorry?
Wrong presentation. I had a small movement there. Saw that.
Presentation.
There we go. I'm Don Kranz. I've been involved in the DMA special project this year. Steve Eusty's in charge of that effort. He couldn't be with us today. He's off doing some other work for IVVO, so he was not able to make it. So I'm going to try and cover the whole presentation today, but I might not do Steve's parts justice. So, this is the abstract that you saw that enticed you to come here, or you were just too lazy to leave the room and the presentation finished. But I think it's kind of important to note in the abstract that the whole point behind the DMA was to try and reduce duplication effort. Software that's currently available is site licenses for the facility, or software that's available as shareware over the internet in this effort. And so far, been fairly successful with that. This is the agenda. I'm going to talk a little bit about the overall effort, the data management architecture, then the AMF, analyst and management framework that we have that you might have seen some things about last year. And then I'm going to talk about improving flow of information, which was important to the DMA effort. And I'm going to show you how we plan on tracking the impact of data efficiencies. I haven't made any specific claims, but you're welcome to take the spreadsheet and plug in your own numbers and see how the formulas work out for you to see if it was a effective way to do things. So the data management architecture is trying to lay the foundation to support a data-driven approach to IV&V. To have data in databases from previous work and current work so that it can be passed through the phases of the project and passed from project to project to improve the information we provide in our analysis and give us more evidence for evidence-based analysis. It's focused on defining components to support principal activities for performing IV&V and managing it. What we looked at when we did the AMF effort last year, we looked at IV&V 09-1, which covers analysis, the actual active analysis pretty heavily for concept documentation, design documentation requirements, test code, a few other things. This year, we focused the effort on doing the data analysis on the incoming data. So we went from heritage review up to the analysis process. And in that case, we translated some of the document that we had, used what was defined for those processes. In other cases, we've been defining and documenting processes that were missing and identifying gaps in the process between processes, kind of the cracks between the processes, as it were. And we're just wrapping up that effort right now. Data management architecture is an umbrella for 3 different efforts that are all highly interrelated with one another. Analysis and management framework, which is the piece that I'm involved with. An operational data source. This is going to be a common database structure and data strategy, and we'll talk about that a little bit later on. And the idea for a data warehouse to allow facility-wide analysis across projects. So this is what got DMA started this year. Our problem statement. I don't think there's anything new here that people don't know. Data resides in a variety of different forms, and that varies from project to project as to how the data is stored. There are some best practices and some developer tools that are passed from project to project and modified as need be for each individual project. The task of rolling that up into a reusable thing is a bit cumbersome as we encounter more and more customization. One of the things in the data management architecture that Steve wanted to point out is the fact that it's a set of solutions. The data management architecture itself is an umbrella for those 3 solutions that we were talking about on the previous slide. And why do we want to do this? We believe we can achieve cost efficiencies far beyond the efficiencies of just handling the data more efficient. They can be gained within the program from being able to analyze trends as we have things in the warehouse, and that'll allow us to make transformations in the processes that we have to really see having this data source available to the facility as a way of exposing more data and relationships that we might not have seen otherwise to help us. As Greg said this morning, we've got to keep evolving and improving, and we see this as a necessary step in trying to make that happen and facilitate it. If you go out to the on Confluence, for those of you here at the facility, there is a website for DMA, and this is the picture you'll be greeted with. This is the vision for the operational data store and the data warehouse. The idea being that here's an operational data store that the project is using. I don't know if I can see that online. Here's an operational data store that each project will use, and they can ask for information from it. And regardless of where that information resides, that'll all be returned as if it's in a single database, and queries and reports and dashboards can be produced based on a single query type of capability. Snapshots of that operational data source will be taken and captured in a data warehouse by the facility. There's a couple of times there may be periodic snapshots at an interval determined by IVBO, or there may be at certain milestones the project lead or the PM may want to take a snapshot in time, especially around deliverables and reviews, um, uh, and have that stored in the data warehouse. The data warehouse will have information from all the projects in there, and will be very important during, especially during project startup with a heritage review, because you'll be able to do queries across multiple projects to start looking for heritage type of artifacts. Is Chris up here? Chris Williams? No, okay. The SWAT team is working on the ODS and the data warehouse portion of this. The AMF, as we call it, the Analysis Management Framework, is a three-tier architecture that we put together in order to componentize the work we do in IV&V. We have a user interface layer, which can be any place in an analyst either requests data or puts in data. We have a couple of everything in the kitchen sink interfaces, like the analyst workbench, which lets you work through the relationships between all the data on your project. We've got a number of MS Office plugins that also will interact with the architecture. And we've just recently added a JIRA interface so that you can exchange data between your analysis databases and what you're capturing in JIRA. The business layer is what is the magical piece that makes this all happen. This defines the domains and the type of behavior generically for the act of doing IV&V. I've called it a meta model for IV&V. And the idea being here is, if we go back and look at this operational data store, the business layer will talk to these, and it handles the ETL processing so that you can ask for something from a user interface, and regardless of where it is, get it returned to you. And then as more and more technologies become available, we've got the data layer, which serves up data to the business in the form of business objects when you query it through a common interface. So when you get a new technology in that has data in it that you want, you merely need to write a new data layer, and then you can reuse that data in any of the UIs that talk using the business object contract that's defined. Excuse me. And the same thing's true on the user interface side. One of the developers we had working on this, it took a while the first time through to do the first UI, because we also developed the business layer at that time. He was very surprised at how quickly the second UI came up, because there was a lot that he says it was already there for me because of the business logic that we have defined. Oops, I keep clicking on the background. So here's a conceptual view of the AMF. You see this user interface layer, whether it's the AWB, Analyst Workbench, Project Workbench, Orbit or an Orbit replacement, Compass, Risk Manager, Lessons Learned, maybe project dashboards on a Confluence page. They all make the same type of request for business objects, and they can work with them to produce work in a format that the IV&V teams are comfortable with. One of the things missing up here is also MS Office is definitely a user interface for obtaining the data. It's just not a data source. I should say not a database. It's often a data source, but we're not using it as a database function. The business objects have been written once for 3 platforms, and they're reused by different products on those platforms. The platforms that we have business objects for are VBA for MS Office, web services for the internet, and Eclipse plugins or Java jars for the Eclipse Java environment. You don't necessarily have to run them inside of Eclipse, but the jars do provide all that functionality for you. And then some of the data layers that we have right now, we have an AMF schema, which we will evolve and swap out the ODS layer for when that becomes available. And we have a number of external sources that we're getting data from today, places like Doors or a project proprietary database structure, or even documentation. Usually tends to be a one-way street with the documentation. We suck it out of there, we put it in one of the data sources, and then we can trace it to the world to work with it. This is an example of one of the user interfaces, the everything in the kitchen sink interface. Neil's going to be going over that in the next presentation, so I'm going to skip over it and try and get a couple minutes of your day back for you. We talked about improving the flow of information. So what were we working on? Basically in FY13 we focused on 09-1, concept through implementation analysis. On FY14 we focused on those things that happen before analysis starts. Things like the heritage review, PBRA, portfolio-based risk-based assessment, the IPEP, a new concept of assurance strategy that IVVO has been working on this year, tying into the technical scope and rigor, and ongoing scheduling and reporting, getting that set up so that you can redo that. So those are the type of things we're looking at this year. To do that, we did these workflow assessments in those areas in order to facilitate our integration towards a database approach. Part of the workflow assessments, we looked at any existing documentation that was out there, and we noted gaps that exist. We made some suggestions for filling those gaps. We also did some operational scenarios that you can find out on the website for how we would like this to work so that the data would flow. And we played each of the workflows off of a common domain model to make sure that the data would flow between each of them. And that's now being applied to the operational data source design and the data warehouse that they're going to start implementation of in FY15. Here's an example of one of the workflows that we looked at was a heritage review. And there was a almost 2-page instructions existing for the heritage review when we started. And it was pretty, it was kind of all over the map and contradicted itself and such. What we learned by interviewing the PMs and Keenan Bowens did a lot of this work with us. And there's actually 16 potential sources of information for the heritage review. And a number of those, I would say at least 9 of them, can be covered with what we've already got designed into the data architecture and the domain models. The other 7 will require modifications to be made, and we've already made a couple of those and coordinated that with SWAT. The other thing we looked at from there was how to extract useful information in order to support the IPEP and the PBRA and RBA processes, and to help in the scoping effort that those 2 processes do before we selected which technical scope and rigor we would be applying to it. This provided a very nice base domain model because of all the sources that we could then test the other workflows against, and we would modify that in order to come up with a common domain model for all of those workflows to use. Okay. One of the reasons we're doing this is to establish some cost efficiencies out there. What we want to do is, not track data in a spreadsheet. We might use a spreadsheet as a user interface to the data, but we'd like to have it in a database. Excuse me. We won't, the amount of effort that's used that could be hidden based on the form and format of the data. There are things that we do in IV&V when we make an analysis estimate. They're just considered part of the job. We said we were going to do this. Well, that means I'm going to deal with these 230 documents and the various versions that came in. We didn't exactly call that out when we were working on it. And it varies. Some documents are better than other documents when you're working with the data. Anyone who's worked with data from documents knows what I mean there. So one of the things this effort has done is actually called out the costs of working with documents. A lot of the things that we show are things you were going to do anyways. You just never recorded the time for them before, and now you're capturing the time. So I have a slideshow here, or a spreadsheet here. Wow. It's short for the woman. Okay, so I wanted just to pull this up just to show you what some of the costs were that you might encounter. This is just a small example, and I didn't put the actual costs in here. You'll be able to download this along with the presentation. But we do have formulas in here, and we have how much effort once you have a full ODS and data warehouse in place, we expect this to take. So let's say I'm importing a document. I don't know how long it takes you to import a document today, but I know it depends on how well structured are the documents, how consistent are they, not only within themselves, but within the project. If every team you interface with in the project has a different format for their documents. You've got a different import process for every one of those. We've made it, one of the key things in the framework is we wanted to make customization simple for you. So things like adding new artifact types, new document types, capturing new pieces of data in places we didn't expect to find it, or that we haven't dealt with before, dealing with new formats, differentiations of formats, can all be dealt with without requiring the need of reprogramming. An example, I taught a class last week, and it was on some of the customization capabilities that we have. And we added a new custom artifact type, and we had a couple of custom data fields to an existing type requirements for the project we were looking at. And we defined the data fields for the new type that we had added to the system. And you were sitting there, what'd that take, 5-10 minutes to define that? Yeah, so it was really easy to do. And once we were done defining those without writing any code, and we then opened up the one of the user interfaces that uses the framework, and there were data entry fields when I was dealing with those type of records, and I had the option to be able to add the new data type without adding any more code to the system. By data type, I mean artifact type. Not only could I do that in the user interface, but the import process that deals with those records as well takes about 5 minutes of information to tell it what it's pointing at, and it'll ingest it for you and do the import, so you don't have to rewrite your import code for this, because they're all, the MS Office and the Eclipse client are both using the same business layer on them. They're both designed off the same layer, and this is a layer that was defined with the idea of being efficient, and with the idea that projects are going to need to customize data to rapidly respond to their data needs, and they're not going to have time to get a programmer to write the code to do it for them. I know a lot of us are part-time coders in the evening, making this tweak or that tweak to working on. One of the other things that you'll deal with cost-wise is with bad data coming in. That comes in a couple of formats. One format is it's just a really lousy formatted document or piece of information coming in, and there's no standards internally to it, and they use non-standard control characters and such to represent things. Or it could be a project consistency thing. And this doesn't have to be in a document. I mean, one of the artifacts we deal with is DOORS data coming in. We had one DOORS database that came in, and there were 32 modules in the DOORS database, and each lead analyst was responsible for defining their module. So we had a good set of, we didn't have 32 sets designs for these DOORS modules. We had about 7, because luckily most analysts were multitasking and had more than one they were responsible for. So those did tend to be the same. But you can deal with those variations in data and be off and running with it. Another area, the project, but within the facility or within the IV&V family, where you save time is in sharing these processes. Right now, we have a lot of, there are a lot of desktop-oriented or stovepipe database applications, and they each do their own thing, and well, I type my issue number in here, so I know it's this issue over in this system, or, I use this import process and I modified it because of my data, and then I give this program to another team and they've got to modify it again because their data isn't in that format. What this does is by being data-driven, even in the definition of the data, this allows projects to more easily share what they've been doing and then modify it based on what their particular needs are for their project. There's also some things that happen that you may or may not have an automated process for. Things like identifying changes. I've got my requirements in and it's a draft version, and then I get a baseline version of the requirements, and then I have to go identify what changed between the two. And it may be changes in common fields, it may be some custom fields that particular project is using. With meaningful data, that's why they put the custom field in there. So you probably have that automated if it's coming from a database, like Doors or something like that. And that works well for you. But how you'll know what changed, but as you get later and later in the process, what was the impact of that on things like design and test plans and code? Later changes are going to have a greater impact. So with this common database that tracks these elements and the relationships between them, when a change occurs to an item, we can identify that, flag it in the database that it had changed from the last release, or it was deleted, or it was new. And we can look at everything that uses it as evidence and flag that as a suspect analysis so that we can quickly say, okay, what analysis am I responsible for that are suspect? And by the way, I wrote this risk against this artifact, and I wrote these 3 issues, and here's my evidence-based assurance based on it. It'd be nice to know that I need to look at all of that information just because I got a new version of the artifact in. And that's what this database approach is using. So if you have an idea of what it takes you to do that now with whatever method you're using, you can plug that information in on the left side. We have some basic numbers for some of these here in the middle, and then you can identify what kind of cost you're putting against that, and what will come out of this is basically how have you improved efficiency from a cost basis, at least, by adopting some of these the DMA frameworks and databases. My screen's going away, so I'm done.
Your screen's going away. You're done.
Yeah. Do you have time for any questions?
We don't have time for any questions. We're going to go ahead and move right on to Mr. Sato.
Pardon?
Going to move on to Neil.
Okay.
Yep. Thank you.